So when we look at a balanced equation, all we see is what the products are and what the reactants are. But it doesn't tell us anything about how the reaction actually occurred. Because reactions occur in a series of small reactions, each called an elementary step. And the series of elementary steps that make up a overall reaction is called a reaction mechanism. So for example, here we have a balanced equation. NO2 plus CO forms NO plus CO2. And we have the rate law, which we determined from an experiment. And so one of the possible reaction mechanisms for this overall equation are these two elementary steps. So instead of this single reaction happening, what actually happens is first we have two NO2s combining to form NO3 plus NO. And then that NO3 that was just formed in the first elementary step combines with CO to form NO2 plus CO2. And so notice when you add these two elementary steps, they add up to the overall balanced equation. And so each of these elementary steps has a different rate constant K and a different rate law. And so for these elementary steps, we can do something special to determine the rate law. Remember that for a balanced equation, we always have to determine it through experiment. But for an elementary step, we can determine it from something called the molecularity. And the molecularity just means how many things must collide to produce a reaction. So for example, in both of these elementary steps, they are bimolecular. And that's because in both of these reactions, two molecules must collide to produce the reaction. Here we have two NO2 molecules which must bump together, and here we have an NO3 molecule which must bump into the CO molecule to produce the reaction. So in an elementary step, the order of a particular reactant in the rate law is just going to be how many of that molecule has to collide. In other words, the order in the elementary step is just the coefficient of that reactant. So in this elementary step, if we combine these, it would just be 2 NO2, so the order in the rate law is NO2 to the second power. And here we have one of each of these molecules, so the order of both reactants is 1. So remember, this only works for elementary steps. In a balanced equation, you still have to determine the rate law only through experiment. And you can see that the substance NO3 is formed in the first elementary step, and then it's used as a reactant in the second elementary step. So that when you add these two elementary steps, it cancels out and it doesn't appear anywhere in the final balanced equation. So a substance like this that doesn't appear in the balanced equation and is formed and used during the mechanism is called an intermediate. So there are many possible reaction mechanisms for a particular overall reaction. And there's actually no way to prove 100% that a particular mechanism is the correct mechanism. So all we can do is see that it is valid. It's a possible mechanism. So in order for a mechanism to be possible for a particular reaction, it has to fulfill two conditions. First, the elementary steps have to add up to the overall balanced equation. And second, the rate law that we get from the mechanism must agree with the rate law for the overall equation that we got through an experiment. And to get the rate law from a mechanism, we have to determine which elementary step is the slowest step. Because an overall reaction mechanism can only go as fast as the slowest step in the mechanism. And for this reason, the slowest step in a mechanism is called the rate determining step. So if we go back to this mechanism, we see that the rate law for the first elementary step agrees with the rate law for the overall balanced equation that we got through experiment. So this leads us to believe that the first elementary step is the slowest step in the mechanism. Because to find the rate law from the mechanism, we just take the rate law of the slowest elementary step. And the rate law from the mechanism has to agree with the experimental rate law for the balanced equation. So for this mechanism, since this rate law for the first step agrees with the rate law for the balanced equation, the first step must be the slowest step.